Hello everyone, December the 19th. Alright, first things first. Keys and rooms. Oh, done this before. N rooms label 0 to n-1, and all the rooms are locked except for room 0. Your goal is to visit all the rooms. However, you cannot enter a locked room without having its key. When you visit a room, you may find a set of distinct keys in it. Each key has a number on it, denoting which room it unlocks, and you can take all of them with you to unlock the other rooms. Given an array of rooms, and rooms I is the set of key that you can obtain if you visit room I. Return true if you can visit all the rooms, false otherwise. Okay, so in the first one, I always can go to room 0 and I get a key to 1, and I go to 1, I get a key to 2, and I go to 3, we get a key to 3, and I go to 3. That's visiting all the rooms. The second case, go to room 0, I got a 3 and a 1. Now I can go to 1, then I can go to 3, but I never get to room 2. Right? All the values of rooms are unique. Yeah, that's fine. And so this is a graph, right? This is a graph. So what we can do is starting from each one, we just create a graph that from a room we can go to another room. Cannot go the other way around. Right? 0 can connect to 1, 0 can connect to 3. To prove, not to prove, to just show, so we can have a better understanding, I'm just going to draw the graph for example 2. So we have 0, right? And 0 can go to 1, 0 can go to 3. Right, from 1 we can go to 3, we can go back to 0, and we can go to 1 itself. From 2 we can go to 2, and from 3 we can go to 0. Yeah, so once we have this, all we need to do is to traverse, right? Man, we actually don't need to traverse. I mean, we can traverse. Yeah, we build this and we will traverse and to see which one has not been visited. Something like that. Okay, can give it a shot. Wait, where are all the others? This one don't need anymore. Yeah, so that's kind of basically the idea. Graph. Okay, then we say for I and keys in enumerate rooms. For j in keys, graph I dot append j. Alright, so we have a graph. Then def dfs, we have a room, which is integer, visited, it's gonna be a set. And this one we're not gonna return anything. So we return boolean value. No, don't return anything. So we go through everything. All right, start from 0, we visit everything, and then we just want to see which one has not been visited. How are we gonna do that? Actually, if you look at this, we have only 1000. So visited, we can actually do visited here. Okay, you can say visited equals 1000. So everything is now visited times 1000. Do we have to do 1000 or 1001? Oh, this is good, right? And then we say if visited room If not, and not being visited, then visited room will equal to 1. Right, and then for next in graph room, we're gonna go DFS next graph, visit them, and then we're gonna call DFS start with 0, and we just return sum visited is it larger than 0, right? So we return true if everything can be visited. If everything can be visited, that's kind of giving me another idea. If everything can be visited, then we can return this. All right. It's a little bit trick, but hopefully it works. Okay. Or rooms. Can visit all rooms. Oh, the first one's bad. That was interesting. How? Oh, for sure. I don't know n. Dang it. They don't give you... Oh, they do give you n. Oh, that's my bad. It should be len rooms. Yeah, it was my bad. There we go. This one should be right. Or... this makes more sense. Alright. Visited, we said 1. And it should be len nums. Len rooms. This makes more sense. There we go. Alright, submit it. I think we got it. Yes, we did. We did got it. Len rooms. Not. There we go. 900. We're getting closer. DFS search. Curious what I used in the past. Oh, I probably do the BFS and DFS. That's probably what I do. Yeah, it's a DFS. Oh, I don't have to create a graph. Oh, it's already created for you. My God, I don't need this. It's already created for you. I don't know. I don't know what I was thinking. I do not know what I was thinking. $841. Yeah, the graph has already been created in rooms. No need to generate a new one. I don't know. I didn't notice this one. Probably that's why I missed the last time too. I don't know. Is that because the last one also... No, I know BFS and DFS last time. It's okay. Whatever it is. Alright. We're done with this. Go back here. So we have an idea yesterday. We just need to execute it. Okay, let's execute this idea. All right, so what we saying? We're gonna have two things. All right, we're gonna have a self.empties. It's gonna be 0 to n minus 1. All right, 0 indexed array. Yeah, that's the empty. What else do we have? Self dot MIDs shall be default dict of a list. Okay, so we allocate, and I also need binary search. And then remember, bisect has an insert. Insert left. Change in 3.10, adding a key. I just need to say insert. Insert left, or insert it to the left. What do you think? Well, what I think is I don't want that. I want to just good old bisect right. All right, allocate. So what we need to do is go through empties, find the first one that's possible, and then try to insert it. All right. So we say for AB, AB, enumerate self.empties if b minus a plus 1 is larger or equal to size. That's what we're going to insert. Now, how do we insert? We are going to insert by, we have this, so basically we're going to break it up. Right, we have A and B, we want to break it up. So from A to something is going to be that, and that's going to be self.empties I, right? 0 shall equal to what? Equal to A plus size, right? A plus size is the starting point. That's the new starting point. So we update the empty. At the same time, we need to handle mids. So we can say self.mids MID, right? Then we need to insert this in there. And then we need to make sure it's still sorted. So we say the list, we're going to call it L equals self.mid MID, right? And we're going to binary search it because we have something inside already, and that's sorted by the front. And we are going to binary search it. And there's not going to be any overlap. So in a binary search A, it's not A, it's going to be yes, A. When the starting point is going to be A. So we're going to binary search this using A. Then we'll find the position. And that position is going to be where we're going to do. So maybe for this one, we can just say insert right. Or we should just call insort. We can call insort. Let's insert x in A in sorted order. X in A in sorted order. What's X? What's A? A is self down mid MID. What's A? Is A, right? A plus size minus 1. That's it. So we put it in, and we are going to return size, right? That's what we want to return. Allocate, return the block's first index. I should actually return A. And if it can't, which means here we're going to minus 1. Okay, so that's in a free. Now free, basically we're gonna say blocks equals self dot mids dot pop MID. That's right? The dictionary has a pop. Not 100% sure. I think so. Hold on. Okay, a dot pop 2. Yep, I think I can pop. So I pop this, I get the blocks, right? And then I'm gonna go through every single one in the block. So we say for A, B in this. And then what we need is to go to the empties. We need to add this into the empties. All right, when they add this into the empties. Now, here is actually not that simple. I just realized, because we might have merging happening, right? So no. Oh yeah, then these two operations basically is the same. So basically we need to have a helper function, def insert. Right, self, we're gonna have an array of array. So we're gonna say it's just gonna be some ranges, which can be list of int, and current range. And R, which is the current range. And I'm not going to return anything. Okay, so we insert R into ranges while taking care of all the merging issue. So with this, so we need to do index, right? Equals bisect right dot, not bisect right, ranges R. Okay, so we have the index. So we say if index is 0, which means this is in the front, right? I'm going to say if index is equal to 0, and it will not be the same, right? It will not be the same. So that's comforting. So if index is 0, then we have to put this in the front. And then all we need to see is, we say if R, you know what? I like this to call it range. Ranges, oh, you cannot use range. Ran, how about this? If ran 1 is smaller than ranges 0, 0. So this is something to the front. Then we say ranges dot insert 0 ran, done, right? Else, because there's no overlap. So if it's smaller otherwise, then they must be equal, and it will not be overlapping, right? Because you remove, you insert, it will never overlap. So else, we simply change ranges 0, 0 or equal to ran 0. We just change it because it almost overlap. Ooh, actually that's not true. minus 1. Because ran1 shall equal, if it's equal to, then we can combine them. But if it's smaller than the front minus 1, so there is basically there's a gap. All right, there's a gap in between. We cannot do that. All right, so we'll insert it. Otherwise, we will say range is 0 because, yeah, so that's that. If elif index is equal to ranges, no, len ranges, basically we'll insert it to the end. Then we, same thing, we say ran 0 this time. If it's larger than ranges minus 1, 1 plus 1, right? Then ranges append ran, else ranges minus 1, 1 shall equal to ran 1. Yeah, we are combining the two. Else, it means there's something in between. Then we have to compare to the front and I'll compare to the end. So we compare to the front, right? So we compare to the front, compare to the end. If neither, then we have to push it in. If one side, ooh, that would be interesting actually. Okay, so we have 3 scenarios. So first is if ranges index, so we say, wait, the index is here, right? So that's the index, as the index minus 1, right? If index minus 1, 1, plus 1 is smaller than ran 0, and ran 1 is smaller than ranges index 0 minus 1, okay? So this is the case, then we just say ranges.insert index ran. There's no other way. Elif, we have to spit out all the possibilities. So we say it's equal in the front, but so it's equal on the left hand side, but it's smaller on the right hand side. And then ranges index minus 1, 1 shall equal to ran 1. Elif, we say this is smaller on this side, but equal on this side, okay? Then ranges index 0 shall equal to ran 0. Else, both are equal. Holy crap. If both are equal, then we are combining these two. So we're gonna do, how do we pop? Do we just pop directly? We say a equals 1, 2, 3, 4. A dot pop index. Index minus 1. So 3 shall be out. A is min, yeah. So in this case, we say ranges. Let's pop the back. Index minus 1, 0, no, 1 shall equal to ranges index 1. Yeah, and then we can say ranges dot pop index. You can pop this. So that's insert. So in this case, self dot insert. When I insert this, right, and then the range is this. All right. So we just gonna say same thing. Self dot insert, self dot empties, AB. Ooh, we can simply just ran. All right, this is just gonna be ran. Okay, so for each one, so we'll pop, right? So we pop this, and then we just increment on the empties. And once we're done, what do we return? Number of memory units you have freed. Number of memory unit you have freed. So we need to rest equal to 0. Rest plus equal to ran 1 minus paren 0 plus 1. And I will return rest. Let's give this a shot. List out of range. That is very funny. Which one out of range? Ranges shall always have something. We might know. Empties might be empty. Okay, well we can do that. Ranges. Oh, we handle here when say if not ranges. Okay, then ranges dot append ran and then return. Okay, let's see if we add this. Key error 7. And if it does not exist, okay. Oh, mids. Mids is, that's fine. Let me just say if, I remember. Default. There we go. That's good. That looks promising. Do we dare? I'm gonna figure something else. Have more. No, I think I'm confident. There we go. Not too shabby, isn't it? Not too shabby. Use self.empties to record all ranges of empty blocks. Use self.mids to record the occupied, right, blocks for each memory ID. The difficulty, the complex part, is the handling of block merges and the block merges when free and allocate and free are called. When allocate is called, block merge happens in self.mids. When free is called, block merge happens in self.empties. The mechanism of these merges is the same. We use self.insert to handle this logic. Overall, I mean, we have insert, so it could be n, the worst case. But I'll ignore that. I mean, this depends on how many empties we have. So worst case is actually because I'm merging them, right? So yeah, I mean, the worst case could be like n, O-N, and insert it could be on. Its insert can be on. It's a log n. It's a log n plus n. So on squared. A worst case scenario, we can call that on squared. Yeah, worst case scenario, I think is on squared. But anyway, two maps, brute force. Oh. That's n constraint. Yeah, we're drawing our chunks. Yeah, about the same. Okay. All right, maximum number of points from grid queries. You're given n by n grid and an array queries of size k. Okay. For an array answer, find an array answer of size k such that for each integer queries I, you start at the top left cell of the matrix and repeat the following process. Queries I is strictly greater than the value of the current cell that you're in, then you get 1 point. If it is the first time you're visiting the cell, and you can move to any adjacent cell in all 4 directions. Otherwise, you do not get any points and you end the process. So we want to find anything that's strictly smaller than this. And it can go anywhere you want to go, only if it's the first time you visit the cell. After the process, answer I is the maximum number of points you can get. Note that for each query, you are allowed to visit the same cell multiple times. Return. So for this one's 5, so we just search. This can go, right? And then we basically don't want to go to the one that we cannot go, right? We're going to go, but you can go here, and then you just say map ending, and then you go there, right? And then you can go backwards. I mean, it's not really backwards. Or is it? Going backwards? Basically just say start from this, how far I can go. Right? Start from this, how far I can go. From this, how far I can go. And then I don't understand. And then we can only go to the places where it's smaller than me. So I start from here, I go this, right? And I start from here, I can go this and this. I don't see. Hold on. Starting from here, I say go here, and I go here. This I cannot go, right? And this I visited before. So I start here, I can go here, right? This I can go here, I can go here. What's the difficulty in this? I don't know. This one feels... Okay, if my understanding is correct, this one seems to be not really that hard. Now, usually when this happens, especially in a difficult question, I think it's me the problem is, but I'm not sure. But anyway, so what we're gonna do, we are going to rest is gonna be 0 times len queries, okay? And then we can call a DFS. All right, so we'll have I and J. All right, we have I and J, and then we need to know the current query. Right, what is the current query? And then we're gonna return nothing. Okay. Oh, I also need visited. visited. Okay, so what's this? Well, I'm at ing, and if I can visit it, that means it's good. All right, that means it's good. So we can say res. Holy moly, we're gonna say k. Res k plus equal 1. That's the current one. I'm visiting the current one. All right, and then we're gonna go visited.add ij. All right, and then we're gonna say for didj in 1 0 minus 1 0 0 1 0 minus 1 ni and j equals I plus di, j plus dj if mn equals langrid 0. Yep. If what? Ni is ni smaller than m and 0 smaller equal to nj smaller than n and ij not in visited. I mean, I can do it here. If ij is in visited, return. Okay, so we don't have to do it here. ij in visited or grid ij is larger than yeah, if it's larger or equal to, because it has to be strictly greater, so queries k. So if it's bigger than it, then we don't do it. Otherwise we'll visit it, and if this, then we just dfs ninj visited. Right, we're going to go through all of them, and yeah, and then we'll just say for k in range len queries. All right, we're going to dfs. Everything will start from 0 0. Right, from 0 0 k. This is going to be a set, and then we'll return res. Okay, let's give this a shot. I give myself a little bit slack, which means this one, if I cannot do it in one go, I guess I will be okay with it. Well, it's always nice if I can do it fast. Max points. Serious problem. Oh, I forgot a K. It's the same K. Yep, I don't know, man. Unless I time out. I could time out. I can see that happening. That's why it's the difficult one, because of timeout. All right. You've proved your point. You have proved your point. Hey, at least we have a how many have we passed? 16. Only passed 16, man. Dude, oh my god. Holy crap. That is brutal. Okay, okie dokie. Yeah, I should have realized that. I should have. realize that. Because they're all connected. They're all connected. Like, if I do a 5, and now I do a 2, then anything that 5 can reach, 2 can reach already. Right? In fact, maybe I can change this query. We can let it go from large to small, right? If we go from large to small, then we have the end positions. Okay, let's try this. We'll sort this query thing. Like, for sure, we're gonna sort this query thing. We're gonna sort it and reapply it to the result. QQ equals, for I, Q in enumerate queries, we are going to call it QI, okay? Then we are going to sort it. All right, reverse. Dude, we have to do this. Sort this and reverse equals true. So we have the largest value at the front. And we have this. These are all fine. All right, these are all fine. Oh. And this is going to be does not matter. Does not matter. What we can do is we start with this, okay? And every time we can do for Q, right? For Q, I don't even need this in QQ. So DFS Q. So this is basically Q and a set, right? Then what? Then what we're gonna do? Oh, how big is this? 1000. It's not too bad. It's not too bad. So I'm going to DFS this, right? DFS this will actually rest.append a 0. And every time we're just going to call it -1. Okay? And then blah, 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 done. And what we need is the end positions. That's what we need, the end position. Okay? So I need the end position. How do we handle the end position? End position is the one that after we go through. No, it should be the spot that we have not. Yes, it should be the spot. So damn. Hold on. Starts. Okay. 0, 0. And then we're gonna call starts. Right. Visited. It's a set. So don't pass it in. Then what? Every time, I can do this, and I can say rest.append land visited. Because every time I just add 1 point. Wait, hold on. That's correct, that's right. Every time we just add the length, and we have starts, and inside we have the starts. No. Nope. 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 because I want to return a new starts. You see what I'm saying? Ah. I think I know what you're saying. I think I do. I think I do. So from each one, QQ, right? And then, so that's the current thing. When you say while Q, blah, 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 and then we go to the next one. While Q, hold on, I'm still thinking. Hold on, I'm still thinking. I'm gonna say for AB in Q, no, in, yeah, Q, U, E, U, E, for AB in Q, when a DFS AB, which is the start, Q is the value, and visited is already there, and we need to pass in the temp. Okay, passing the temp, and this should be the next starts. Should be a list of int. If something is visited, we return. If ij, no, if grid ij is larger than the current Q, then we say next starts dot append ij, right? We'll put ij into the next starts, and then we return. Then we don't do anything. We say, okay, we visit this, blah, blah, blah. We say the next one with a Q, and we do next starts. Okay, so we do this, blah, blah, blah. Once we finish everything, actually it's not. It should be for AB in Q. So temp, I'm gonna put in here. Okay, for AB and Q, I handle this. Once I'm done, Q need to be equal to temp. Then this is gonna append this. And once we're done, so there's no result in here. So the result, there's no result. Result will be here. So we're gonna say, alright, well, there is a result. Should be unsorted result. Meshed result. Meshed. Mixed result. Okay. And then rest will equal to 0 times 0 times what? Len queries. Okay. Then for R, for this I, no. For Q, this I, R in zip, QQ, and mix results. Res I shall equal to R. Then return res. Give this a shot. 888. That is not right. That is not right. Okay, don't panic. Let's see what happens. So before we can actually say, let's see what's the Q, and let's see what is the makes the result. Q is this, makes the result is 8. What? That is not what I had expected. What's QQ? QQ is 6, 1, right? So we start from 6, which is bad, right? And then I got 1, 2, 3 times. What in the world? Doesn't make any sense. Hold up. So that'll be 0, 0, right? So 0, 0 in, Q is 6. And then boom, the first one, we say that's no good. It's not in visited. No. It's not in visited. This is here is 1. Oh, I did this. Ah, why do you sort that way? Why do you reverse? Small to big. Small to big. I don't know why I say big to small. It doesn't make any sense. Small to big. So the smallest, we have the smallest range. All right. Alrighty. Let's try this. If I can pass, that means we're on the right track. Damn. We do pass, but let's take a long time. It's kind of my strategy is to keep track of the edge. And for each one, because we sorted, so it'll always be bigger, right? And I always start from the edge. Not sure. Let's see. I mean, this one's already causing 3,000 milliseconds. The last time thing 16. 17! We only passed one more. Okay. This is not good. This is not good. Not good. Not good at all. Man. Oh. Yeah, I think everything only visited once, right? I mean, what if I... Do you think it's gonna make any difference? What I know is I can make this a set. I made this an add. No. I'll think something else tomorrow. Well, I'll leave it here. Interesting problem, huh? I'll see you guys tomorrow. Adios.